Welcome to day 14 of the low-level design course. Today we will focus on two powerful and essential structural design patterns, the adapter pattern and the bridge pattern. Both of these patterns are aimed at making our system more flexible, decoupled and extensible. These patterns are vital when we are building systems that need to interact with other components or evolve over time. Let's dive right in. By the end of today's session, you should be able to understand the purpose and structure of both the adapter and bridge patterns. Know when and why to apply each pattern in your system design. See how these patterns work through UML diagrams and real-world examples. Finally, we will have a practical coding session to reinforce these concepts. So let's start by setting the stage with a quick review of structural design patterns. Before we delve deeper into the adapter and bridge patterns, let's first recall what structural patterns are. Structural design patterns are used to simplify the way classes and objects are structured. These patterns help define relationships between different objects or classes, making it easier to organize and scale the system. The adapter and bridge patterns both fall under this category and focus on improving flexibility, modularity, and extensibility in your designs. Let's begin with the adapter pattern. In simple terms, the adapter pattern allows us to convert one interface into another that is expected by the client. Think of it like a plug adapter we use when traveling to a foreign country. It allows us to plug our electronic devices into an outlet with a different shape or voltage. Similarly, in software, the adapter pattern acts as a bridge between incompatible systems, allowing them to communicate with each other without needing to change their internal implementations. This pattern is typically used when you want to reuse an existing class but its interface is incompatible with the rest of your system. Now, when would you use the adapter pattern? You should consider using it in scenarios where you have an existing system and you need to integrate a new system or component without modifying the existing code. A common case for using the adapter is when you are working with legacy systems that were developed before your new implementation, and you need to connect them without disrupting the overall architecture. The adapter pattern helps maintain the stability of the existing code while allowing you to integrate new functionalities seamlessly. Let's now take a look at how the adapter pattern works using a UML diagram. As you can see here, we have three key components. The client, which expects to interact with the target interface. The adapter, which implements the target interface and contains a reference to the adaptee class that has the incompatible interface. The adaptee is the existing class with an interface that the client needs to use but does not match the expected target interface. The adapter in this case converts calls from the client into calls that the adaptee can understand, enabling communication between the two. Let's see this in action with a simple C++ code example. Here we have a class oldPrinter that has a method oldPrint, but our system expects a printer interface with a print method. To solve this, we create an adapter class that implements the printer interface and internally calls the oldPrint method of the oldPrinter. This allows the client to use the oldPrinter without modifying the original code. You can see that the adapter works as a wrapper around the oldPrinter to make it compatible with the new interface. Next, we move on to the bridge pattern. While the adapter focuses on making incompatible interfaces work together, the bridge pattern is all about decoupling the abstraction of a system from its implementation. This means that both the abstraction and implementation can evolve independently, which makes the system more flexible. The classic example here is the relationship between a remote control and the devices it controls, whether it's a TV, fan, or air conditioner. The remote does not depend on the specifics of the device, but rather on an abstraction of the device behavior. You would use the bridge pattern when you have a system where both the abstraction and the implementation need to evolve independently. A common use case would be when your system has different types of platforms or rendering technologies that need to work with the same abstraction. The bridge allows us to change the implementation without modifying the abstraction and vice versa. In the UML diagram for the bridge pattern, we have the abstraction class, which defines the high-level control flow. The refined abstraction extends this abstraction. The implementer interface provides the low-level implementation details, and the concrete implementer class contains the actual implementation. The key point here is that abstraction and implementer are separate, allowing for independent evolution. You can swap or modify the implementation without affecting the abstraction layer, making your system more flexible and extensible. Let's look at a code example for the breach pattern. In this case, we have a device interface that defines methods like turn on and turn off. The remote control class uses a reference to a device and can run it on or off. The beauty of the breach pattern is that you can add new devices like fan or write without changing the remote control access. You can simply implement the device interface in new concrete classes. This separation ensures that changes to device behavior won't affect the remote control, and changes to remote control functionality won't require modifying individual classes. Let's now compare the adapter and breach patterns side by side. The adapter pattern is used to make one interface compatible with another. It's generally used for integrating different pre-existing components. The breach pattern, on the other hand, is used to decouple the abstraction from its implementation, allowing both to evolve independently. The adapter is typically applied after the system is built, while the breach is usually applied during the design phase when you foresee future changes to either the abstraction or implementation. Here are some real-world examples to clarify these concepts further. Adapter pattern. Imagine you need to integrate a legacy payment system with a modern e-commerce platform. The legacy system uses a different interface for payment processing, and an adapter would allow the new platform to communicate with it without altering the legacy code. Breach pattern. A good example of the breach pattern is a graphics rendering engine. It could work with multiple rendering technologies like OpenGL, DirectX, or Falcon. The renderer abstraction is decoupled from the specific rendering technology, allowing you to add or change technologies without altering the engine's high-level logic. Now it's time for a quick hands-on exercise. For the adapter pattern, create an adapter for an old media player that can play audio files in a format that isn't natively supported by the modern system you are working with. For the breach pattern, design a system where you can control different payment gateways like credit card and PayPal using a common abstraction. The key is to ensure that the payment methods are decoupled from the payment gateway logic. This exercise will give you practical experience applying these patterns. Let's recap what we have learned today. The adapter pattern makes incompatible interfaces work together without changing the original code. The breach pattern separates abstraction and implementation, allowing both to evolve independently. Both patterns are powerful tools for maintaining flexibility, extensibility, and decoupling in your system designs. The key takeaways is that understanding when to apply each pattern will lead to cleaner, more maintainable, and scalable systems. For your homework, I recommend solving a few lead code design questions where you can apply either the adapter or breach patterns. Additionally, read the relevant chapters from the Gang of Four book to gain deeper insights into these patterns and explore some advanced use cases. I'm looking forward to seeing how you apply these patterns in your projects. Thank you for your attention.